All right, so we're going to talk through on this video the first page, the front page of the quiz number 1, and then I'll make another video for the back page. So the thing that I wanted to note as we're looking through this piecewise function, I would recommend, if you're in a situation like this, and especially if part A is starting to feel weird, like you're not sure exactly how to do it, graphing the function is always a good step. So remember that you have kind of 3 parts. When you look at these, you should be thinking, what kind of function is this? The second part is easy. You've got a constant function, right? Which should be a horizontal line. So when we see that, we have this horizontal line here. Now I put it dotted because this is the whole line. In our function, in our piecewise function, we have it restricted. But right now we're going to look at the whole thing. And then these other 2 parts, notice you have x to the first power, and that's your only and your highest power in this function. So that means this is going to be a line. It's got a -1 slope, and it crosses at -3 if you look at slope-intercept form. And we've got something that looks like that. And then the third one also is a line with slope 2 and also crosses at -3. Okay, so we have these 3 lines that make up the different pieces, but we want to restrict those. Okay, so in black we have our restrictions in. So, and it's pretty straightforward to see how they're restricted. Our red dashed line was anything less than or equal to -2. So we got this part here. Our horizontal line was between -2 and 1. And then anything greater than or equal to 1, we used our green dashed line here to fill in. Now you probably already saw this point up here. When I put in a value of -12, -12 is way over here. Well, that's in this range here, right? Or this domain. This part of our function represents that. So I need to plug in -12 here. So if I plug in -12, then I get +12 minus 3, so I get 9. So that's what you see here. We have a value of 9. Our next spot was at 0. And you can see, of course, when we go to 0, that now we are in this middle section here. And so anything in this middle section, any output obviously has to be -1. There's no other option. So anything in this middle part is -1. So we had an input of 0 gives us an output of -1. If I went back to that -1 spot, I'm still there, so I still am at -1 for an output. And then once I get over here, I go to 1. Well, it looks like it's on the same part, but really, when I'm exactly equal to 1, then I need to use this third portion here. So if I put in 1, I get 2 times 1, that's 2, minus 3, so I'm at -1. So part 2, part 3, and part 4 all have a solution of -1, but part 3 is actually evaluated on the third part of the function. Now the other thing that you'll note here is that these are lines, and because the endpoints of each piece of the domain, so for example, my first part includes -2, and then the second part goes everything past -2 up to 1, but doesn't include 1, and then the third part includes 1 and goes on to infinity. So we fill in the whole domain. So from -infinity to +infinity, every input value, every real number input value is going to work just fine. Now when we're talking about our range, we can see that these lines go off for ever, so they go to infinity. But down here, I don't have anything that ever gets less than -1. So my range is going to be -1 with a square bracket, because I include -1, to infinity. And always for infinity, since that's really just a concept of saying it goes on and on, we use that parenthesis, the round part. Okay. So hopefully that makes clear to you of how to approach a problem like this. When you're dealing with a piecewise function, remember, it's just a domain-restricted parts, and you want to figure out what the shape of each thing is. I would always suggest starting with a graph and kind of developing your other pieces from there. All right, so now we'll go on to the back page for the second video.